wrap it up pretty like quickly because I guess it's everyone is tired. It's the last day and everything. HTTP end of the road. Like yesterday, there is like a huge disclaimer here. We're not gonna see cake PHP stuff again, like yesterday's presentation. And for those of you who already hate me, there is a second disclaimer that we're gonna talk about something that is really, really old. So it's all almost as me. The agenda. The history of the HTTP protocol. Okay, we're gonna have a look at some hidden features, mostly the HTTP cache. We're gonna talk about HTTP 2.0 and SPDY. First of all, what is the current version of the HTTP protocol that we're used to? Which version of the HTTP protocol do we use nowadays? Okay, 1.1, yeah, that's it. And we're all web developers, right? So we're used to deal with the HTTP protocol every day. The thing is, for us, it's pretty easy, okay, to interact with a web page. You just boot up your laptop, blah, 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 blah. It's easy for everyone except my mom. You should see her. The thing is, what about machines? Because for you, if you get a 404, you don't even like need to know the status code, right? You just look at the page. It says, "Oh, we fucked up or we screwed up. The results are not available." So you understand that there is something wrong there. But what about the machines? Well, basically they need rules, logic. Okay, there's a 404. There's a redirect. I'm going to expect a location header, which is going to tell me, okay, you should follow this redirect and go to this URL. They need domains, they need workflows like redirects, and they need verbs. Verbs like get, like post, like put, like diff, head, delete, patch, which are all valid HTTP verbs. And they need constraints. And the bottom line is, yeah, constraints are protocols, because they say, given A, I'm going to expect B, right? Now, it was, 23 years ago. It was the second year of the Gulf War, right? It was 1991. What do you say about Italy were there? Gonna have some fun. Thing is, what happened in 91? Actually, we've seen the first official release of the HTTP protocol. Okay, it's something that it's almost 25 years old. And then, a few years later, it was pretty unusable. I mean, it was very rough, very primitive, of course, but it's let HTTP 1.0 come out. What happened? Basically, 5 years after the release of HTTP 0.9, we had Tim Berners-Lee. I mean, how many of you do not know Tim Berners-Lee? Perfect. How many of you do not know Roy Fielding? That's bad. You know why? Because Roy Fielding, in his PhD thesis, it was like, I think 15 years ago, he talked for the first time in the web history about something that he called representational state transfer, or REST. Okay? So this guy is the guy who invented REST, basically, the formal definition. So they were working on the HTTP protocol, so they actually released version 1.0, which included some more verbs like head, like post and get, compared to the previous version. You could use separate connections. You could only use separate connections, so you could actually not use the same connection, which was a killer for latency. And then, on the same year, they reviewed it, and they came out with HTTP 1.1. So actually, what you're using right now is almost 20 years old, okay? Almost 20 years old. I think you have a new release or a new minor version of Cake or whatever framework every 6 months, right? Can you believe that these guys 20 years ago built something that is still working? If I build something, in 2 weeks it's gonna break. I don't know about you, but that's the average for me. what they did is like, okay, in 1.1, let's add some more verbs because clients need to actually have some different workflows to represent some different scenarios. So they add those. They remove the need to separate connections to scale up. So basically, like you can just use one connection and make multiple requests. And then they introduce something. I mean, they finalized actually something that it's what lets the web scale at the level that we know. Because if you think about it, the web is the largest data exchange network on the planet. The HTTP cache, why is it so fascinating, at least for me? Because we forgot about it. So they actually gave it to us and we forgot about it. So what happens? How many of you have ever used the HTTP cache? E-tags, stay while revalidate. Okay, perfect. So what happens? Your client actually makes a request and it gets a response back. It gets a response with an e-tag, which is an identifier. Let's say if you have an object, okay, you can just serialize it and say, okay, that's my e-tag. Okay? It's a representation, like a definition of the object. The second time that the client will request the same resource, so users 1, it will say, okay, but tell me if it has been modified, because if it has not been modified, I can reuse the one that you sent me earlier because I cached it. The server says 304 is not modified. It sends an empty response with a 304 status code. This lets you save bandwidth, okay? Because you don't have to send anything. It's just an empty response, and the client reuses what it has in cache. If actually it has changed, while you verify that it has changed, you just send a precondition field, okay? This is when you want to actually modify them. So you have an API, you say, okay, I want to change this user. The latest version that I had is that one. Can I change it? No, because you don't have the latest version. Precondition failed. This header, the e-tags and if non-match, if match are called preconditional headers, which let you do preconditional requests. And what happens in the browser when you navigate a web page? It's the exact same thing. For example, you have the max age directive in the cache control header, which says, okay, I can cache this stuff for a minute, 60 seconds, okay? Second time that I visit the same resource, I don't have to traverse the network. The browser will serve it to me, because all the modern browsers implement the HTTP cache for free. I mean, you don't have to pay for it. They built it. They've built the specification 20 years ago, and we can still use it. So how do we do caching, basically, on the HTTP protocol? We can only do exploration and validation. Invalidation is impossible because it means that everyone has to keep track of the server. They always keep a server connection with the server open and say, okay, please invalidate all these clients. So exploration. This is a very simple HTTP request. Okay, it says expires 0. It means that it's not cacheable. Okay, you can set the date, and which means that this response will be cacheable until that date, of course. Or you can use like the cache control header, which is slightly more complex, which lets you mix a few things. Like you say, I want to have this resource cacheable for 1 minute and for public caches. What are public caches? Proxies and browsers, okay? If it could only be cached by private caches, only browser could cache them. Because maybe you're like sending sensitive data and you don't want a proxy to cache them. Because what is a good thing about public caches? That if I'm like behind a company firewall, if a guy in front of me is actually like from his desktop requesting a web page, when I'm gonna request it, I'm gonna get the cached version that has been stored with his request. And some more complex things like fault tolerance. Stale if error. It means for 10 minutes, if my application is actually down, okay, if you get an error, a 500 something status code, you're just gonna serve a cache response. So your application is down, but the user can still see the web page that has been cached by your reverse proxy or by the browser itself. stale while revalidate, which means that if you don't have a cached version at that moment, serve a stale response, forward the request to the origin server, and recache it. So basically what happens, I'm going to request a resource, right? I'm gonna get like a users one, an API, a representation of a user. At that point, after 10 minutes, it gets stale, so it's invalid. It's outdated, right? But the second user who's gonna actually go there and request it will get the cached version, which is probably out of date, but it will get the response, and the proxy will actually forward the request to the server so it can revalidate the cache. So the third user that comes in gets a new version. So basically you have one client that gets an outdated version. If you actually want to scale, this is one of the good ways to do that. Because you have one client that probably gets an outdated version and 10,000 clients that don't need to hit the origin server. How do you do that with validation? It's a little bit more complex and scales less. But it lets you like be more granular. As I said, we just provide an e-tag for our resource, okay? So it's basically just an identifier. Say user one or whatever as a e-tag 1, 2, 3, 4. Good. Then the browser asks you the second time that makes the same request, asks you, has it been modified? And you can say just no, 304. Because the thing is, you have to just calculate an e-tag. You don't have to make database queries to render the view and bootstrap all of your framework, okay? You just say, okay, let me just calculate the e-tag with the minimum amount of code that I need to, and let's see if it matches or not. And then you can just say 304 not modified, just use what you have in cache. Same thing with the last modified header. If you had created that and updated that field in your database, that's perfect. Basically, the browser, you tell the client, this resource has been modified last at this date, okay? And the second time, it will ask you, give me this resource only if it has been modified since that time, okay? Same thing, relax. You just have to retrieve a date and then compare it. If it doesn't match, okay, you go on and you just serve the response as you would do normally. But if it matches, if it's fine, if it hasn't been modified, 304 not modified, almost 0 bytes in the response. Thing is, okay, this might work pretty well for APIs, okay? But for like websites and so on, let's say that I have my homepage, it has a few posts, they can be cacheable for an hour, but then I also like retrieve server side, like some tweets and so on, and they have to be updated like every minute, right? So I have a part of my page that has a like very short time to leave, but the rest actually can be cached for more time. And you say it's ineffective? No, because Oracle and Akamai, do you know Akamai? I mean, it's the biggest CDN provider of the world. I think they know about performances. They invented a standard called ESI, edge side includes, that it's built exactly for this, that lets you cache fragments of your page. And a cool guy that we will also like, we will hear about him later, Mark Nottingham, has invented HI include, which does the same thing that ESI does server side on the client side. It basically does that with JavaScript. At the end of the day, what does the HTTP cache is meant to solve, basically? I mean, first of all, less work. Because everything that deals with caching, with saving, with checking dates and so on is delegated to the proxy or to the browser, okay? So you don't have to do it. I don't know you, but I honestly don't trust my code 100%. I trust more projects that are like Squid, like Varnish, like Nginx that have been out there since like 10 years maybe. And they have like hundreds of committers behind it. And they're used by like probably 1 million websites all combined. Evolve. Because the thing is, you don't have any caching layer in your application. Less code, less bugs, right? because an application without code has no bugs. It's useless, but the more code you add, like you have more chances to find bugs. So you have less things to maintain, you delegate, you use like proper tools that have been invented since ages, and you have to care less, you don't have to care about that particular aspect in your own application. You don't have to upgrade it, maintain it, it's less work. And loose coupling, of course. Because actually, one entire functionality of your application, caching, it's tied to a protocol that will never change, will never change. It's there since almost 25 years, right? What might change a bit, we will see it later, but the semantics will never change, the semantics of the HTTP protocol. Well, your implementation can be actually different. You can have whatever framework behind that. Thing is, we've just ignored all of these things so far, because it's nice. Let's build our own caching layer in Joomla, Drupal, wherever. Let's not look at what like real engineers have done to actually make the web scale to the level that we know. For 22 years, which is pretty funky. So we've seen, okay, but since 1996, what has happened around HTTP? There were like a lot of proposals, but it's a pretty stagnated situation, right? So like since a couple of years, there has been like some talks about renewing the protocol, rewriting some things and so on. But so far, there is nothing that's tangible, okay? We don't have nothing on hands. So at that point, let's say 1 year ago, by the time I first gave this presentation, there was some cool thing that came out, and it's called SPDY. And as you might know, it comes out from Google, which is another company that I think knows a lot about performances over the web, right? And wants to make the web experience faster. So SPDY is a protocol that has been actually invented by Google. It only runs on HTTPS. It uses like a super duper extended compression and some other things that make it like very, very fast. You can read the white paper and the specs at this link. Thing is, you're already using it. Even though you log into Gmail in Chrome and you say https mail.google.com, you're using SPDY in the background. And it has been implemented by Chrome, Firefox, Nginx, and I think even like Apache has like not a major support, but it kind of supports it right now. So if you want to implement SPDY and you're using Apache, you can do it. If you're using Nginx, you can do it. It's a version of HTTP on steroids, which means it has like a few cool things that you can do with SPDY that you would never be able to do with HTTP because of technical limitations, okay? Like request prioritization. So you say, in the HTTP protocol, you say, I'm just going to send the first request, the second request, that's it, the third request, that's it. You can maybe parallelize it, but you can't prioritize them. In SPDY, you can actually say the second request, this request, is more important than the other ones, okay? And the server will fulfill them accordingly to the priority. It has compression. It is true that you can JZip stuff at HTTP level, but SPDY uses like an enhanced compression that makes actually like everything faster. Another thing is multiplexing. Do you know what it is? Perfect. So this is the request-response model, right? So we send a request, we get a response. We send another request, that's it. In HTTP, you can already do pipelining. So if you know that you're going to send like multiple requests and you wanted to parallelize them, you just pipeline them. So you send a couple requests and you get a couple requests back. It's in parallel, okay? You can't avoid that. In SPDY, what happens? They do multiplexing. So you send a request, while you get a response, you send another request over the same connection, and then you will get the last response. And server push. So basically, a server that uses HTTP SPDY can actually, after serving a response with the same connection, push additional informations to the client natively, or whatever. The result is that actually SPDY looks very, very good. If you compare it to HTTP, the way it looks now, it's really advanced. And what was the side effect of this thing is that after 14 years, after the last review, which was in 1999 of the HTTP protocol, okay, they said, okay, let's get serious about HTTP 2.0. It's like, yeah, they're coming on us. And this guy, Mark Nottingham, we were talking about him before, right? He works for Akamai. Strange. He's in charge. It's one of the chairmen of the HTTP 2 working group, okay, 2.0 working group. And 1 year ago, they were like, okay, it's official, we're actually working on it. So what happened? Since we have to do a lot of compression, the biggest change following what SPDY did in the HTTP 2.0 protocol, which is now taking shape right now, is that you can't do all those telnet connections or whatever, because the problem is it's going to be a binary protocol, just as SPDY is. It's not like a revolution. If you actually wanna like go with performances, yeah, you go binary. So the thing is, these HTTP requests will look funky in a bit, okay? But that's not a big deal, because you will have tools like HTTP Py, HTTP Party, curl, that are gonna do that for you. So nothing is gonna change for us at the end of the day. You can read about like all the improved performances that being binary brings into the table. And this is how requests will look like. So we will just say, okay, I'm a client, I understand, I can understand the HTTP 2.0 protocol. So if you want, you can upgrade, you can switch protocol and upgrade it. We can also like not just use the HTTP 1.1 version, but if you want, let's upgrade to 2.0. There is an upgrade header, and that's it. So the thing is, it's not the only thing that HTTP 2.0 is doing. It's not that it's just going to be binary. It will also have all the good things that you get with SPDY. Why? Well, because basically it's built over SPDY. Okay? I would recommend you to have a look at this presentation, What HTTP 2.0 Will Do For You, by Mark Nottingham, again. The thing is, you say, okay, they just copied them. Yeah, kind of. But the fact is that SPDY is based on HTTP 1.1. Because the semantics are not changing. It's just the technical implementation that changes. Let's say I have an API, get apples, I get an apple, and it's built with cake. I just change the application. I will use Rails, but I will still have get apples, return apples. It's just the technical implementation that changes, not the semantics. It just changes the way that messages, HTTP messages, are going to be exchanged over the wire. That's it. The semantics are the same, the workflows are the same, the verbs are the same. The HTTP interface, the interface between clients and servers, will always be the same. In fact, what Nottingham said is that in order to replace HTTP 1.1, the minimum thing that you have to do is to actually include everything that it has, okay? To replicate the semantics. You can't break it. Can you imagine that tomorrow we deploy a new version of the HTTP protocol that breaks the web? It's kind of scary. So here, backwards compatibility, it's very important. Thing is, an HTTP 1.1, it's mostly based on HTTP 1.0. 17 years ago. And nothing has radically changed since then. an architecture that actually lasts 20 years, it's impossible. And there is one guy who actually worked on these things. His name is, again, Roy Fielding. We're talking, because this guy on his PhD thesis, he spoke about REST. And what he also said is like, usually engineers are good at short-term design, but they don't look at the big picture. So these guys have been in charge of actually making the web, creating a protocol that would let us scale, and they did it. And they didn't have to fix it every week. They released 3 versions, and it worked for 20 years. That's it. I have 4 minutes. I guess most of you already seen me yesterday. I'm Alex. My Twitter handle. I work in Dubai for Namshi, where I'm VP of Technology. And you can find me at hub.odino.org. And thanks for listening. If anyone has questions,